Good afternoon.
Good afternoon, sir.
Good afternoon, sir.
Okay, is the screen visible? White screen, white board.
Yes, sir.
Yes, sir.
Okay. So in the last class we have started with the friction. Okay, we are solving the numericals on the friction part. Today you will be having unit test, correct now?
Yes, sir.
Okay, so entire second chapter from the equilibrium of rigid bodies to till the friction. Okay, there will be maximum portions from the friction part also. Theory and beam. Okay, beam theories and
Sir,
spears. Okay,
background voice लो येते.
background.
Background voice बहुत आ रहा है.
Madam, sound. Okay, so now you can hear me.
Yes, sir.
Okay, fine.
सर आप क्या बता रहे थे अभी कुछ समझ नहीं आया.
Okay, for the unit test 2, the syllabus will be entire second chapter, that is equilibrium of rigid bodies. Okay, next problems on the beams and also problems on the friction. Okay,
Okay.
so there will be maximum questions from the friction because friction part I have taken recently. It was not there in your ISC. Okay.
Yes, sir.
Now, whatever MCQs I have given for the for your class, that MCQs you have to be thorough. So in the last class we have started the problems on the friction part. Okay, we have taken one problem, that is problems on ladder. Okay. That we have found out, correct? No?
Yes, sir.
What was the P value? P value 61.76.
61.76.
Have we got that answer?
Yes,
Calculation kar diya?
Yes, sir. Correct.
Okay, fine. So take down another problem. Next problem. Question. The ladder shown in figure shown in figure is 6 meter long, and is supported by a horizontal floor and vertical wall. The coefficient of friction between the floor and ladder is 0.25, and between wall and ladder is 0.4, full stop. The self weight of ladder is is 200 Newton, 200 Newton, and may be considered as considered as concentrated at G, concentrated at G. The ladder also supports a vertical load of 900 Newton at C. 900 Newton at C, which is at a distance of 1 meter from B. 1 meter from B. Determine the least value of alpha. Determine the least value of alpha. Determine the least value of alpha at which the ladder may be placed. At which the ladder may be placed without slipping. Determine the reaction developed at the stage. Determine the reaction developed at that stage. So this kind of problems will be asked for 8 marks. Okay, the figure is given already. Okay, this is the ladder. So the length is given
6 meter.
that is total 6 meter. Okay. 6 meter. So again he has given this is a vertical wall which is in rough, and also there is a floor which is in also rough. Okay, so he has given the point A and point B. This is point A at a floor and point B at a wall, and the self weight is acting at the center of the ladder. Okay, the self weight is acting at the center of the ladder, and the name he has given it is G point. G. What? How much is the self weight? The self weight of the ladder is 200 Newton. It is 200 Newton is given. And AB. So you have to determine this value of alpha in order to stop the slipping. Can you tell me what is the length of AG? A to G.
3 meter.
Yes,
Meter.
3
meter, and the remaining is 3 meter. Okay. Have you taken this diagram? Okay, I'll put it on this diagram. So I will write the free body diagram of a ladder. Okay, this is the free body diagram.
सर सी पॉइंट रहेगा है ना
Yes, C point is acting from the B. It is 900. Yes, correct. I will take C point. So it is a C point, and the load will be. It is 9. How much it is? It is 900 Newton.
900 meter
900 Newton. It is acting at a point C, and the distance between C to B is how much? He has given 1 meter.
1 meter
1 meter from B.
1 meter.
From this point to this point, it is 1 meter. 1 meter. Okay. So I will draw the free body diagram of the ladder. So first of all, the self weight is acting at the center. Okay. So this is the self weight acting, and there is a 900 Newton force is acting at a 1 meter from the point B. So this is 1 meter from the point B. Okay. So when this is a ladder is resting against the wall, then at point A, friction is developed, correct? Okay. Is it in the direction of right hand direction, left hand direction? At a point A, friction is developed. Right hand. Okay. So this is the friction is developed. And how will be the normal reaction? It is upward or downward?
upward
Upward. Okay. In the point B, how will be the normal reaction? At a point B.
Left side.
Yeah,
Left
it is
side.
horizontal and that is left side.
Left.
Normal. And the point B, the ladder is moving downward, correct now? Then how will be the friction at this point? B?
Upward.
It is
Upward.
upward. It means all of you are getting, okay? How will be this? Okay, and is there any other forces? No, only these forces. So I will write all these things. At a point A, this is A, this is a point G, this is a point C, this is a point B. Yes, at a point, this is a friction at A point, and this is normal reaction at A point. This is self weight, that is 200 Newton, and this is 900 Newton, and this is a friction at point B, and this is a friction. Normal reaction at point B. Is it understood, everyone?
yes sir
Yes, sir.
Okay, all of you draw this diagram. Okay, free body diagram. So this is free body diagram of ladder. FBD of ladder. FBD of ladder. So at A point, he has given the mu value. At A point, he has given mu A. So solution. Mu at A point is given. How much? What is the coefficient of friction at a wall and ladder? Floor and ladder. The coefficient of friction between the floor and ladder is 0.25.
0.25.
0.25. And again, the coefficient of friction at the ladder and the wall, between the wall and ladder is 0.4. 0.4. Okay. We know that what is the coefficient of friction? We know that from the laws of mechanics. What is coefficient of friction? Mu is equal to what?
Equal to F of
Yes.
F upon R.
F upon R. That is no, frictional force divided by normal reaction. Correct, enough? So if I want to find out the coefficient of friction that is at A point, then Fa upon Na. So this implies, can I write this is friction at a point A is equal to mu at point A into Na? Is it okay? Okay. So it means friction at mu at A point is 0.25. 0.25 into Na. And also friction at point B is equal to mu at B into N at B. So mu at B is 0.4 here is given into N at B. Okay, is it correct?
yes sir
Okay. What he has asked, we have to find out the value of alpha in such a way that the ladder should not fall down. Okay, it should resist also. It means I have to determine Fa, Fb, Na, Nb. While you are finding all these things, you will come to the point alpha. Okay, that value you have to find out, and also all the reactions you have to find out. Okay, so first apply sigma V is equal to 0. because already F either you have determined FA and FB. Okay, so find out sigma V is equal to 0. So summation of sigma V is equal to 0, that is summation of Fy is equal to 0. Summation of Fy is equal to 0. Okay, what are the forces which are moving in vertical direction? Can you tell me?
NA
Plus or
FB.
minus? Plus NA.
plus
Plus NA.
minus 200.
Minus
NB.
200 as minus 200.
Minus
Minus 900. Okay.
plus FB. Plus
Plus
FB.
FB. Plus FB is equal to 0. Okay. So here, what I will do, I will write all the things in terms of NA and NB. NA as it is, I will write NA. FB is equal to 0.4 NB. Okay. So I will write plus 0.4 NB. NB. This is equal to, it is 1100. So I will take this is equation number 1. Is it correct?
Yes, sir.
Okay. Next,
Yes,
I will
sir.
take again sigma fx is equal to 0. Sigma fx is equal to 0. It means all the forces which are moving in horizontal direction is equal to 0. Okay. Now tell me, what are the forces which are moving in horizontal direction?
FA.
FA is plus FA. Okay. Next.
Minus NB.
Minus
Yes,
NB.
minus NB. Okay. Next is equal to 0. Correct? Na?
0.
So what is FA? FA is equal to 0.25. 0.25 NA. Correct? Minus NB. NB is equal to 0. So I will take this is equation number 2. Equation number 2. So substitute equation number 2 in equation number 1. So substitute equation number 2 in equation number 1. Substitute equation number 2 in equation number 1. Okay, equation number 2 NB है, so NB value इधर substitute करेंगे. So equation number 1 क्या है? NA as it is NA plus 0.4 NB. So from this equation, what is NB? So that is
0.25.
0.25 times of NA. NA is equal to 1100. Okay, so you solve this equation, you will get the value of NA. Can you tell me the value of NA? So NA plus 0.4 into 25, that will become
0.1.
0.1.
0.1.
0.1 times of NA is equal to 1100. So that is NA is equal to 1100 divided by 1.1. That is equal to 1000. NA is equal to 1000 Newton. 1000 Newton. Is it correct?
Yes, sir.
Yes, sir.
Are you calculating now?
Yes, sir.
Yes, sir.
Okay. So this is the value of NA.
So तिथे डबल NA म्हटल्यावर 2 NA येणार नाही.
NA plus 0.1 NA, 1 NA plus 0.1 NA, 1.1 होता है ना? 2 NA कैसे होगा?
Yes, sir. 1.1.
1 plus 0.1.
Yes.
Either 1 है, either 0.1 है. 1 plus 0.1, that is 1.1. Okay. So next, so you got the value of NA. Once you figure the value of NA, can you find out the value of FA?
Yes, sir.
Okay. So this implies FA is equal to first. So NA is known. So this implies FA is equal to. So FA is equal to, what is the FA? So this is FA value. That is 0.25 into FA. NA is equal to 1000. So you will get 250 Newton.
Yes, sir. 250 Newton.
250 Newton is FA. Next. So once if you know the value of NA, okay, so substitute in the equation number 2. So from 2. So substitute 0.25 into NA. NA is equal to 1000. Next is equal to NB. Okay. So NB is equal to 250. NB is equal to 250 Newton. Then, so if from this equation, you know NB. So again, substitute in this equation, FB is equal to. So FB is equal to 0.4 into 250. So FB is equal to,
100 Newton.
it is equal to
100 Newton.
100 Newton.
100.
It means I found all the values of alpha, that is all the values of reactions. Okay, so Fa is known, Nb is known, Fb is known. Okay, what I want to find out, my intention is what? Intention is I need to determine alpha. So
Alpha.
how to find out the value of alpha? Can anybody tell me? How to find out the value of alpha? I got all the reactions. Here he is asking determine the reaction and developed at the stage. Okay, I have determined all the reactions. How to determine the value of alpha? Yes. One person told. What is that?
Summation of moment.
Yes, very good. Taking moment about which point? About A. Okay, that is algebraic sum of all the moments is equal to 0. Okay, so when you take moment about this point, okay, apply F and NE. Is it producing any moment?
No,
No.
sir.
No.
No, sir.
Why?
They are
Passing
passing.
the given point.
Yes,
To given
they are
point.
passing through the given point. Okay, next, this 200, is it producing any moment?
Yes, sir.
Yes. How
Yes,
much it is?
sir.
Wait, is it 200 or 250?
200.
200, correct. Okay. 200. Is it clockwise movement or anti-clockwise movement?
Clockwise.
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 Plus, that is 200. You know? Yes. Force is 200 Newton. 200 into what is the distance from A to G? A to G inclined length is 3 meter. But I want this force is making in perpendicular distance. Perpendicular distance A to G, perpendicular distance I want. That is sine or cos? I want
Sine.
this. No,
Sine.
No,
this
cos.
this distance I want. No, base, that is cos. You have to find out.
Yes, cos.
3 cos alpha. 3 cos alpha. Next, 900 Newton. This is also producing clockwise movement. So plus 900 into. So from B to C it is 1 meter. Then remaining A to C is how much?
5 meter.
5 meter.
5.
So 5 into horizontal distance. 5 cos alpha.
Cos.
Into
Yes, sir.
5 cos alpha. 5 cos alpha. Next, again, is there any other forces? Yes, there is a NB and FB. NB is how much? NB is how much it is? 250. Is it producing clockwise or anti-clockwise? NB.
Anti-clockwise.
Minus. What is the value of NB? That is 250. 250. This inclined length is 6 meter. Okay, so NB is moving horizontal. I want vertical distance. Vertical distance. How will you find out? 6 sine alpha into 6 sine alpha. Okay, next I want FB. FB is producing clockwise or anti-clockwise? Anti-clockwise. Minus. What is the value of FB? FB is equal to 100 Newton. 100. I want horizontal distance. That is into 6 cos alpha.
Cos alpha.
Alpha is equal to 0. So in all the equations you are having sine and cos. Okay, you simplify all these equations, you will get the value of alpha. Okay, 200 into 3, that is 1200. Okay, so 1200 cos alpha. Then 900 into 5, 4500, correct? Plus
Yes, sir.
4500 cos alpha. Next, minus 250 into 6, 250 into 6, 1500 sin alpha. 1500 sin alpha. Next, 1000 into 100 into 6, that is minus 600 cos alpha. Cos alpha is equal to 0. Okay, so 1200 cos alpha, this is 600 cos alpha, only 600 cos alpha. 600 plus 4500, it is 5100 cos alpha. Correct? 5100 cos alpha, 4001.
So 200 into 3 कितना?
क्या?
600 होता है सर.
600 आना
हाँ, correct. This is ना? Yes, this is only 600. Yes, correct. So this 600 get cancelled. Correct? So you will get only 4500 cos alpha, 4500 cos alpha, cos alpha is equal to 1500 sin alpha. Correct, na? Sin alpha.
Yes, sir.
Okay, so solve this equation. So how to solve this one? 4500 divided by 1500 is equal to sin alpha divided by cos alpha, that is equal to tan alpha. So you would cover this 3 ones are 3 threes are, that is equal to 3. Tan alpha is equal to tan alpha is equal to tan alpha is equal to 3 you will get. So when you take the alpha is equal to tan inverse of 3, you will get this. Can anybody tell me? Calculate है क्या आपके पास? Tan inverse of 3.
71.56.
71.56.
71.56
56.
degrees. 71.56 degrees. Okay, this is the answer I want. Okay. So I want this answer. He is asking this one only. Is it clear, everyone? See what all I have done. I have taken only sigma fx, I have taken sigma fy, and I have found all the reactions. But my intention is I want to find out the value of alpha. So in order to find out the value of alpha, I have used equation, that is moment equation. Okay, so take down all of it. Roll number 7. 13. 19. 31. 38. 52. 53. 63. Okay. Absent numbers 7, 13, 19, 31, 38, 52, 53, 63.
हो गया सर.
Everyone, all of you. Others, have you completed? Yes, reply me. Whether still you are writing or what? You are completed.
Complete.
Everyone, is there anyone who is
Completed, sir.
is there anyone who is still remaining, who is still writing? Okay, I will assume that everyone is completed. Okay, so I have taken two problems from the ladder chapter. Okay, I will give one problem for you homework. Okay, you have to try. If you are not getting, then we'll solve that in the next class. Can I go for the next slide?
Yes, sir.
Okay, all of you are done that problem. This was the question from the question paper. It was asked in December 2018. December 2018 for 7 marks. Okay. A ladder weighing 600 Newton is to be 100 Newton is to be kept in position in position as shown in figure, as shown in below. Okay, as shown in figure or is shown below. In figure, okay. It is resting on. It is resting on a rough floor. A rough floor and rough wall and rough wall. Determine the horizontal. Determine the horizontal force F. Horizontal force F required. F requires to be applied to prevent the sliding, the sliding of ladder when a 700 Newton man stands on the position of B, on the position of B. Stop. Consider AB is equal to DE is equal to 0.625 meter. Assume coefficient of friction as 0.4 on all the sets. This is the ladder which is given. This is the rough wall. So the self weight is how much it is? 100 Newton. The ladder weighing 100 Newton. Where this 100 Newton is acting? Here this 100 Newton is acting. Is exactly acting at the center of the ladder. Again, there is a one more force. The man weight is a 700 Newton. Man stands on the position B. Consider AB is equal to A is given 62 point. Okay, so when you consider this is a man's weight, and there is a force of F is applied at a point, this point. Okay, so here he has given man's weight is 700 Newton, and self weight of the ladder is here it is 100 Newton. 100 Newton is given, and there is a force F is applied in order to stop the slipping. Okay, so this point is A point. This point is B point. This point is B. This point is B. Man's standing is at a point B, and center of the ladder is C. So F is applied at a point E. So this is a point D. This is a point D. This is D point. Okay. He has not given the value of theta. You have to find out the value of theta. So, but he has given the value, that is horizontal length, distance and vertical distance. He has given this and he has given this. That is 1.6. This is 1.6 meter and this is 1.2 meter. 1.2 meter. And he has given the value of AB and DE. AB and DE are acting at the same distance. Take this point is, this is E point. This point is E. This is C. This is C. Okay. He has given this. Means A to B is given. C to D to E point is given. Can you find out the value of B to C and C to E? Total is how much? A to D. Total A to D is he has given. Okay, you have to find out A to D. So how to find out A to D? He has given vertical length and he has given horizontal length. Can you find out the inclined length?
Yes, sir.
Yes,
sir.
you can find
Yes,
out by applying Pythagoras theorem. By applying theorem. So can you find out the value of theta? Yes, tan theta is equal to 1.6 divided by 1.2. So you will get the value of theta value. You will get the value of theta. You will get the value of ED. Once if you get the value of ED, BC is equal to BE, that is CE, because DE, he has given AB and DE are same. AB is same and DE is same. Height BC and CE should be same. Okay. So
Yes.
will you solve this problem? Or I have to solve?
Yes.
क्या करते हैं? So आप try करिए.
नहीं सर,
Okay. Try करिए.
try करिए.
So I will give all the answers. Okay. So A to D. AD answer I will give. AD you have to try. AD is equal to 2 meter. 2 meter. And theta is equal to 53.13 degrees. Next, BC. Okay. So BC is equal to 0.375. 0.375. Next, I will give NA&D. Okay, NA&D. NA is equal to 318.33 Newton. ND is equal to 672.66 Newton. ND हो गया. Next, you have to determine the value of F. Okay, main intention is you have to determine how much is the value of F. F is equal to 49.22266 Newton. Okay, so try करिए. So in case if you are not getting, then we will take this problem in the next class. So note on the answers also. All of you.
सर इसमें भी ये दो होने चाहिए ना
कौन सा F?
फ्रिक्शन
Friction. F at D, F at A. You have to find out. I will convert that F at A and F at B. So either F at D रहता ना इधर.
यस सर
हाँ, this will be convert. So F at D is equal to convert करो. कैसे convert करते? He has given coefficient of friction. F at D is equal to 0.4 times of ND. Correct? So इधर एक friction है, upward friction. F at A is equal to 0.4 times of NA. Correct है ना? Okay, but I have not taken. Just normal direction I have taken. But main intention is this one. You can find out like this also. FD, if you want FD and FA, you can find out that also. I have given NA and D, so you can calculate FA and FD. Okay, you can try this one. All the answers I have given. We'll take that problem in the next. Is it? Have you written? Have you taken?
Yes.
Okay.
Yes, sir.
Can you go for the next point?
Yes, sir.
Yes. Okay. Just a minute. Whether the screen is visible to everyone?
Yes, sir.
Okay.
Yes, sir.
The syllabus. What is remaining in the syllabus? Okay. Equilibrium of coplanar forces we have seen. Analytical graphical is not there. Okay. Just there is a definition, that's all. Different types of supports, free body diagrams, Lami's theorem we have completed. Friction, types of friction, limiting friction, laws of friction, static and dynamic friction, inclined planes, ladder, support reactions, statically determined beams with point load, inclined load, uniformly distributed load, uniformly varying loads, and couples. We have taken all the points. Okay. Then point is principle of virtual work concept only, introduction to a force in space. Okay, a small portion is remaining that we'll see. Okay, what is this virtual work? Virtual work is the work done by a system of forces acting on a body in the equilibrium. When the body is in equilibrium, due to the imaginary consistent displacement
Sir.
is called a
Sir, slide. Sir,
Sir,
slide.
slide 9.
slide. No, okay, wait. Now is it visible
Yes, sir.
Yes, sir.
Yes.
with full screen?
Yes, sir.
Yes. Okay. So syllabus दिख रहा था ना? आपने have you seen syllabus?
No, sir.
Okay.
No, sir.
One second, I will read. Now is it visible? Syllabus unit 2.
Yes, sir.
Okay.
Yes.
So in the 2.1 we have seen equilibrium of coplanar forces, analytical method, okay, and graphical method. In the graphical method, just we have seen the principle, that's all. Then different types of supports, free body diagram, Lami's theorem. We have taken all the points. Then coming to the point, friction. Friction, types of friction, limiting friction, laws of friction, static and dynamic friction, inclined plane, ladder, supports reaction of statically determined beams with point loads, inclined loads, and uniformly distributed loads, uniformly varying loads. Okay, all these points we have seen thoroughly, we have discussed. The point next is 2.3, that is principle of virtual work and introduction to forces in space. Okay, only this point is remaining. That is only concept, theoretical part. Okay, we will see that point. Okay, so next point is that is principle of work, virtual work. Okay, so first of all, you should know what is work. Work is equal to what? Work is equal to, can you tell me what is work?
Force and
Definition.
displacement.
Yes, force into displacement. That is the work. Virtual work means the work done by the system of forces acting on a body in equilibrium. The body should be in equilibrium due to the imaginary consistent displacement. Imaginary consistent displacement is called as virtual work. Okay, the word we have to consider imaginary consistent displacement. That's all here. Okay, work is equal to force into displacement, but here the work done by a system of forces acting on a body in equilibrium due to the imaginary consistent displacement is called as virtual work. The term virtual work means that the displacement does not really exist. Virtual work means the displacement cannot be seen. Okay, that cannot be really exist. It is virtual. See, actually the virtual meeting बोलते हैं ना, अभी online चल रहा है सब. So can you see me? Virtually we can see, but in physically in front of you, can you imagine me? Can you?
No, sir.
You can
No.
see me physically? No, you cannot see.
No, sir.
Correct. Online you are using. The same way, the term virtual work means the displacement does not really exist. The displacement is only assumed to be exist. we have to assume that it is exist, so that we can compare the various possible equilibrium positions and determine the correct one. Just we have to see the virtual work, that's all. So in principle of virtual work, if a system of forces acting on a body in equilibrium undergoes an imaginary displacement, the total work done by all the forces must be equal to zero. Thus, if the system of forces, whenever there is a body, if that body is acting a system of different types of forces, then the body is in equilibrium. If the body is in equilibrium, then by and it undergoes an imaginary displacement, then the total work done by that forces is equal to zero. It is an example. I will take this. Okay, this is a body. Okay, this is acting by so many different types of forces. Okay, if the body is in equilibrium, means it has gone imaginary displacement. Okay, it has undergone imaginary displacement, but ultimately the body is equilibrium. Then the total work done by all these forces must be equal to zero. This is the principle of virtual work. If a system of forces acting on a body in equilibrium undergoes a imaginary displacement, then the total work done by all the forces must be zero. Is it clear? Principle of virtual work? Am I audible?
Yes, sir.
Yes. Okay. Suppose if you consider this is a body is there, this body is acting so many different types of forces. If the body is in equilibrium, okay, if the body is in, okay, the body is subject to different forces. If the body is in equilibrium, okay, finally it is come to this point, it is in equilibrium, then the total work is equal to virtual work is equal to zero. This is not okay. Then the force in space. So whatever you have seen till now, all the forces are in 2D. It means it is in plane. So when you consider this is a plane, okay, the plane means this is x and y axis. This is x and this is y. The force F is lying in this xy plane. Okay. So in the space means there is a 3D. Okay, x direction, y direction, and z direction. Okay.
कट होतोय आवाज मधून मधून.
हाँ सर, वो ऊपर की स्लाइड लो ना सर, वहां से बताओ, कट हो गया था.
Okay, forces in space. You would say previous slide.
No, principles of virtual work
Okay.
diagram.
A virtual work. Is it audible? Was it audible? ये clear हो गया ना?
Yes sir, ये नहीं वो diagram.
हाँ, okay. हाँ, ये diagram है ना?
Yes sir.
हाँ, okay. So इधर दिया है ना, principle of virtual work means whenever you consider a body, okay. So if this is a body, if this body is acting by different types of forces, system of forces. If the body is in equilibrium, अभी audible है ना?
Yes sir.
Yes.
So if this body is in equilibrium, then it has undergone some imaginary displacement. Okay, I cannot measure it. It is virtual. Then the total work done is equal to zero. Total work done is equal to it is zero. Then the total work done by all the forces must be equal to zero because the body is in equilibrium. It has undergone imaginary displacement. The principle of virtual work means if the system of forces acting on a body in equilibrium undergone a imaginary displacement, then the total work done by all the forces must be equal to zero. So for this, the example is next slide. See, this is an example. This is a body. The body is acting by four forces: P1, P2, P3, P4. So it has gone displacement, but it is in equilibrium. Finally, it is in equilibrium. Okay, it means P1, P2, P3, P4. Now, what is the work done? Work done is equal to zero. Okay, this is as per the principle because the body is in equilibrium for that reason. So next point is forces in space. So it means when you call it is a plane, when there are only two axes. This is x and y. X and y. Okay, if the force F is acting in this plane, which plane? Force is acting F in which plane? It is xy plane. Correct? In
Yes.
xy plane. So whenever there is a two-dimensional is there, then that is xy plane. Or you can take yz plane, or you can take zx plane. Okay, but in this case, the axes are in the three dimension: x direction, y direction, and z direction. Okay, x axis, y axis, and z axis. If the force is force in this direction, okay, then you have to determine the components along each direction. When the force act in different planes, not a one plane, then they are called forces in space. If the force acting in one plane, then that is plane. If the forces are acting in a different planes, then it is called as space.
Repeat सांगा sir.
Okay, see, in this one case, x and y, so it means it is plane. It is plane. Only दो axis है तो it is plane. That is 2D. इस ये केस में कितना है? X, Y and Z. How many axes are there?
3.
3. Right? This is 3D, 3-dimensional. This is 2-dimensional. This is 3-dimensional. Okay, if the force is having only one plane, then that is plane frame. If the forces are in different planes, then that is 3-dimensional or it is space. Okay, then you have to determine force in x component, force along y component, force along z component. Okay, so how to determine this value we will see in the next class. Okay, and how to determine the resultant value. When the force is in space coordinate, then how to determine the value of resultant we will see in the next class. Okay.
Yes.
Okay.
So
This is the last point in the second chapter. Okay, afterwards it's complete. Yes, tell me.
G63 is present.
G63 is present. G63 is present. Okay. Next. Okay. Once
Sir,
again.
roll number 38 present.
Yes, I will tell one more time absent numbers: 7, 13, 19, 31, 52, 53. Okay.
Sir, 53 present.
53 present. Okay. 52, 31, 19, 70, 7, 13. Okay. So remaining we'll take in the next class. So today you have unit test 2. At what time?
5 to 6.
5 to 6. Okay, fine. Okay, we'll stop now. We'll continue next class. Thank you all.